Uh-oh, I went outside. Now I have dissimilar. All right, so we're talking about thread direction, pipe threads. Pipe threads. All right. Pipe threads are tapered. That's the word I wanted. Are tapered to give an air/fluid tight fit. Are tapered to give an air/fluid tight fit. All right, so as you screw it together, it gets tighter. As you screw them together, they get tighter. I'll tell you a story. Oh, my glasses defog. So in these fittings, I just refer to them as AN fittings, and there's all different kinds, as you can already see just looking at the little picture. You know, you've got this type, you got another one over here, here's what I'm on here, here's one. This is a bulkhead fitting, by the way. And so you have all these different AN fittings, but blue means something. It means it's made out of aluminum. If it's black, it's made out of steel. So aluminum is lightweight. The point I want to make here, especially with dealing with pipe threads or any kind of aluminum threads, when you're doing aluminum into aluminum, it can gall up and basically weld itself together at room temperature. So I was in the final stages of building a Lycoming engine, and there's a cap on the back. The threads are about that big around. It's almost 2 inches. And so it's a kind of a rare fit, and it's just this cap goes on as a spring and a ball. It's the oil pressure relief housing. And I was just screwing it together by hand. I don't even think, I was checking fit or something. I don't even think I was intending to put it together all the way at this point. And as I'm doing it by hand, I just stopped moving. Oh, well, that's weird. Must be a little booger on there. So you get the wrench out, and no, that didn't go anymore. You can see the thread, and it's that far from going all the way down. Like, well, that's weird. It didn't want to go. I'll just take it out. Nope, not going to take it out either. It was done. It welded itself. This is right there. It's done. And we're talking about, $20-some thousand engine that, to take a case apart and start all over again. I'm going to need new bearings. I'm going to have to send it out for, repairs. I mean, this is like awful. And it's like supposed to go out tomorrow kind of a thing. So... well, at that point, it's like, well, it's there. What are you going to do? So I forced it off. What else, So heat it up helps, warm it up, make sure it's warm, expand it. It didn't help. So, I just kind of forced it out. And yeah, it just pulled a bunch of metal out. And then, fortunately, I found somebody who had a right-sized tap for that. And so I was able to pack it full of beeswax and then tap it and clean out the threads. Most of the damage was on the cap. And so then I just tossed the cap, had a new one, clean out the threads. But it could have gone the other way. It could have been the case would have been bad, and it would have been horrible. So, that I promise you, that was the absolute last time in my life I've ever screwed aluminum into aluminum without anti-seize or oil. I prefer anti-seize on aluminum. That was the last time. So, and I'm telling you, I was just doing it with my fingers, and it just stopped and welded. I'm like, you wouldn't believe it if you weren't there. You'd think that to come in after me would have been like, no, there's no way you did that. You were obviously forcing it on with the wrench, and it got to a certain point, and you just couldn't go anymore. I'm like, no, it was seriously with my fingers. So put anti-seize on your threads. If you're doing engines, you always put oil anyway. Pipe sizing is not intuitive. Let's see. Pipe sizing is not intuitive. Like, you're not going to measure it. So when I showed you that pipe chart. I'm not going to write this. Never screw pipe into a non-pipe fitting. I might as well just write, don't screw things that don't match together. It's like, obviously. I can't see a freaking thing. Okay, break time has now been
extended.
No, the opposite. It's been canceled until further notice. If I go outside, then my glasses get all the temperature difference. All right, types of taps. Only if I breathe out. It works for a while. All right, we have all different kinds of taps. So, I use an electric shaver. That's because of the alcohol. Good point.
Or diver's tricks. I know,
I'm not going to spit.
Toothpaste actually works.
Yeah.
Toothpaste and spit does work really well.
Yeah.
Yes, you spit into your goggles and just wipe it around.
That makes sense.
Or they have an actual anti.
Toothpaste works really good.
Where's the tube of toothpaste?
Hey, when I lost my phone in the river and I had to dive for it, I smeared the inside of my goggles with toothpaste because it kept fogging up on me and it worked. It smells like real minty though.
What are you doing?
I hear honey works too. Why don't you try that? All right. Types of taps. I got this. 3 types. Well, the alcohol didn't work. Just wasted a bunch of good scotch. All right. Taper. Taper. Let me show you a picture. Taps, taps, taps. Threads French. There we go. Taper, plug, and bottoming. So your taper, as you can see, you don't have a lot of threads at all to get it started. So you can kind of get it down and centered in the hole, and then you start. But if you were doing a bottoming tap, like if you had a hole that actually had a bottom to it, then your threads, from about here to here would be non-existent, right? Then you had one that's not quite as aggressive, so plug tap, and then you have a bottoming tap where actually only a few threads, what's that, 1.5, are actually tapered. So you'd be able to get all the way down to the bottom. So if it were me and I had to tap a hole that had a bottom to it, I would start with the chamfered, and I would go all the way down with the chamfered, being careful not to actually touch the bottom because you could break them. And then I would use the bottoming tap. And I will tell you, these things are made out of hardened steel, tool steel. So because they're so hard to keep the edge on them, they're a little bit brittle. And generally speaking, your day is not going well when you start working with taps. Your day goes to absolute dog shit when you break one of these. I mean, it just doesn't get much worse than that. Some of my worst days, I didn't have very many bad days in aviation, but I can guarantee you most of them revolved either around somebody that crashed an airplane or a tap that broke. So don't break a tap. I mean, that is it. Do not break a tap off. If you do, you're probably not going to get it out because it's hardened tool steel. You can't drill it. And if you try and drill it, what the drill is going to do is go off to the side and drill next to it. So now you've ruined the hole. And if that hole is in a very expensive part, you've ruined the very expensive part.
What do you do when that breaks? Right? Do you just leave it and get a new part?
Fall to your knees. Cry.
Cry a lot of tears. Like how would you be able to get that out? If you can.
Hopefully it broke above
Yeah.
the hole. Well, because you got the flutes or the what do you call it, the edge part where there's no thread.
Yeah, the flutes.
You can kind of back it out if you're lucky.
Yeah.
But you gotta find a tool that's gonna get down in there and reverse it. I've been able to do it, but it's not easy at all.
This is usually the part where I feel like I was always called in. Kevin, I broke a tap off. Well, first thing you have to do at that point is not be in a hurry. And so I will get not standard drill bits, but cobalt drill bits, very expensive drill bits. and then you have to set up a fixture some sort, or if I could take the part off, I would take it all the way apart and put it on a mill, which is just like a very heavy duty drill press. But a mill is much more stout, has a lot less flexibility to it, and then I would try and center drill it. If you can get left-hand drill bits, they're even better.
Oh, yeah.
So that it's going left to go in, so if it grabs it, it pulls it out. So it's just little tricks. Get it hot, expand the hole, lots of fluid. It just sucks. It just does. Yeah. Okay. So don't break them. You know, it sounds easy to say that, but that's just the truth. Don't force it. You know, so I use very small handles for these things, and I don't grab them. You know, I just 2 fingers, and if it feels a little tough, man, I stop. I figure whatever, you know, if it can take 100 inch-pounds, I'm putting 50 on it, and I'm maxing out. And so little tiny bit, back it off. Little tiny bit, back it off. And if ever it feels like, oh, that didn't want to go, I'm done. I'm out. So taper for starting threads or threads in thin metal. So for starting threads or threads. That's not even a word that I wrote. Threads in, gotta scroll up. Thin metal. We have the plug that is used after a taper tap to cut threads near the bottom. Cut threads near the bottom. And then we have the bottoming. Bottoming. Used to cut threads nearly to the bottom of a hole.
What would you use to get all the way down to the bottom?
That's it. Bottoming is all you get. Yeah. You could take a bottoming tack and grind on it or something. I don't know. It's just, there's no reason why you would need threads all the way to the bottom of a hole, because the fastener that's going to go in it should not go to the bottom of the hole anyway. Method. So how are you going to do this? Use a tap chart to determine the correct size. So method. You got to drill the hole, you got to make a thread. What are you going to do? So use a tap chart to determine the correct size hole. To drill. Well, you might be thinking to yourself, under what circumstance would I ever be randomly drilling a hole in something airplane related whereby all of the information wasn't given to you? Because usually if you had to drill a hole, you bought, I don't know, you have some kit, some STC, something where you're supposed to add it to the airplane, it would come with exact instructions. It would say drill a number 7 hole exactly here. Then using a tap that is 1/4-28, you shall, and it goes, so why would you just be left to your own devices? Well, you probably wouldn't be. But you know what you end up doing a whole lot in aviation is making things. You're always making a tool or a fixture or a jig, and you got to do something like this. Well, you got to know how to do it. So let's see, tap chart. So there's my tap chart. So you guys have seen those on the wall, right? Okay, so you're just going to take a look. So if I want to do a 1/4-28, I'm going to need a number 3 right there, 1/4-28. This one says 1/4-28 requires a number 3. Yeah, nope, that's a number 3. Or a 5/16 18 would be a F. I want to say, let me see. You guys all ask for a number 7, right?
Yeah.
That's for quarter 20.
Quarter 20, right? Let's see. See if we can find quarter 20 on here. Where's my quarter 20?
Top right.
Thank you. Quarter 20, number 7. How about that? Quarter 28, number 3. And if you're looking at metric stuff, get a different airplane. All right, use a tap chart. Let me see. We did that. Okay, 2, you're going to drill the hole. Drill the hole. And obviously you want to use a drill press or something that gets the hole straight. Otherwise it's going to be crooked the whole time. Use a taper tap. Taper tap for initial. For your first hole. So lubricate well. I cannot think of a situation where you over lubricate something. A little is good, a lot is almost always better. So use cutting oil. Or my favorite, beeswax.
Is that just because it holds the?
It's a great lubricant, and it does hold all of the chips. So especially when you're working around engines, you know, and I wish it happened way beforehand, like when the crankcase is laying on the table and there's nothing else there, and you go, oh, I gotta, you know, tap that or helicoil that. No, it's always when you're putting it together, especially the older the engine is, the more it's gonna happen. I worked on a lot of antique radial engines, and you're putting it together and you're torquing it. It's like, come on, come on, come on. Oh, shit. You know, it's just like, all right, pull it out. And, you know, sometimes you got a lot of assemblies that had to go on to get that. And so it really sucks because you got to take all that apart. And then you go in there and the engine's half up together. So I'll pack the tap. I mean, just pack it, all the flutes, everything with beeswax. And then put towels around everything, vacuums, you know, make sure no chips can get in there, and then you'll tap it, helicoil it, and then of course then you're done. You're like, oh, I did it, you know. And then you put it all back together, and then you start with that one, and then you go to the next one, and it does the same thing. You're like, oh, come on. At that point, you just do them all. Helicoil. All right. So taper tap, lubricate well. Let me see, 2, 3, 4. No, not 4. So A, lubricate well. B, do not force. Shouldn't have to write that, but there are people that will. Usually 1/2 to 3/4 turn forward and then back off. And I think I told you already in lab, when you're cutting those threads, it's like when you get a hangnail and you grab it and pull it. It's like, I think by the time you got to here, it'd be down to your bone. I don't know, I've never tried it, but you know what I'm talking about, right? Yeah.
Go that way. Go that way.
Oh, well, okay, that's what happens when you're cutting these threads. It's kind of like it, you know, you'll get metal built up in there, and then it just gets deeper and deeper. So you go 1/2 to 3/4, then go back till you break off that chip, then 1/2 to 3/4, back off and break it off. You have to keep doing that the whole way off, the whole way down.
The slower you do it, the better.
The slower the better. Okay. So this breaks off chips and keeps threads from cutting too deep. This breaks, B-R-E-A, breaks off the chips and keeps the threads from cutting too deep, and keeps threads from cutting too deep. Repeat with plug or bottoming tap. as needed. All right, if you have to do pipe threads, you gotta be real careful. If you are cutting pipe threads, stop when the ID, what's ID? Inside diameter is correct. Because the more you go, the wider they're going to get, because it's just tapered from the start all the way to the end. So you keep going, it keeps going and going, and then you have the pipe piece that's going to thread into that. It goes all the way down and stops and doesn't get a fluid tight fit because it hit the shoulder of the part and you just messed up. So you don't want to do that. At that point, then you got to helicoil the whole thing.
You have special pipe thread or pipe taps?
Just a pipe tap. It's not special. It's just a pipe tap.
Is there pipe thread helicoils?
Yes, they do make pipe thread helicoils.
Really?
Yes. Okay, dies. Dies. They may be fixed or adjustable. Fixed or adjustable. Let me see my pictures here. Let's see, we got the pipe, the handles. I prefer the smaller ones myself. All right, dies. Fixed, right down here, or adjustable. These are adjustable, both styles. So this adjustable one has a little screw here, and the more you put the screw in, the more it's going to push that, the more it's going to spread it out. Those are almost a little bit easier. You guys will be using this style right here, and I got to tell you, a little itty bitty tiny adjustment goes a long stinking way. So when you're trying to make class 1, 2, and 3 fit threads, I always try and do the 3 first because it's the hardest. If you get the 3, then all you have to do is screw it in a little bit, and that's going to get you the next one and the next one. But don't try and do, so if you're going to do like, oh, I'll do a 16th turn, don't do a 16th on one side and do a 16th on the other, trying to center those things. Don't do that. Just do a 16th on one side. Just a little tiny bit on one side. Also, there's a start and a not start end. Like this one right here, you can see how these threads right here are out chamfered right there. It's wider, and then you have the full threads here. Okay, so it's, yeah, oh, of course you can see that. This is where you start it. So this is upside down. You turn it around and go down on the part that way. So just take a good look at it. Make sure you're starting it in the right spot. Otherwise, it's really hard to start it with full threads. You really got to work at it.
Do you prefer the fixed or the adjustables?
Fixed. Get in, get out, I'm done.
I just didn't know if people like to make like minuscule adjustments sometimes.
No, but these things take all damn day.
I couldn't agree more. I was just making sure.
I think I'd prefer this style right up here because they don't get out of adjustment really. It's just they're set and they're fine. But my tap set in my toolbox is a fixed set. I've never had a problem because you're just not really tapping things in aircraft. You know, you're tapping tools or something, and that's fine. Class 1, 2, or 3, 4, I don't care. It's just a tool. It'll be fine. If I'm working on an airplane, I'm just going to use a thread repair nut or throw it away. So dies, fixed or adjustable. Well, if adjustable, start with die in wide position. Not all the way wide, but obviously wider than what you want. And then if threads are too tight, recut with die slightly smaller. If it's just barely too tight, I wouldn't adjust at all. I just run the thread, I would just run it back over one more time, see if that works. Too tight, recut with slightly. would die slightly smaller. And to repeat as needed. You have a much harder time if you're trying to make your class 1, which is really sloppy, and then, well, I'll just make it bigger as we go. What I do is I try for the class 3, and if you screw up and it's too loose, okay, well, that's 1 or 2 then. Try again. Let's see. Use plenty of oil. Plenty of cutting. Oil. Same process. 1/2 to 3/4 turn forward, and then back to break off those chips. I think that's all I have to say about that. Thread repair. Which, as I've already alluded to, you do a lot. You do a lot of helicoils. There's magnesium was used in aviation quite a bit. Magnesium is really soft, and it's really common to pull threads out of magnesium. In fact, it's funny. Most people will come to me and go, there was a helicoil, and I pulled a helicoil out. I'm like, let me see, and they'll actually kind of pull this thing off their bolt and show it to me. And it looks like a helicoil, but it's not. If you try and expand it, it just breaks because it's brittle. It's magnesium. So magnesium, you just pull the thread straight out, just like a helicoil. It's like, well, look in there. It's very smooth. And so you get into doing. You gonna be all right back there? Mm-hmm. Okay. So you do a lot of helicoil repair. Now, one thing that I don't even know if I'm going to write it down because I have to be careful about this one. And this guy taught me this. So we were doing, working on engines, of course, it's where you're always doing it. And the thread's pulled out. So, well, I got to helicoil it. So you go and you get, if you guys have done it, what's the first thing you got to do?
Make the hole.
Yeah.
Got to what?
Make the hole.
Make the hole?
Drill the hole.
Right. So you pull the threads out, so you get a drill bit. No, don't do that. So now you got to be really careful with this one, but this is good. This was great advice. He told me, he goes, don't do that. He goes, look, if you've already yanked the threads out to the point where there's no threads left, the hole is pretty close to the right size. If you take a drill bit, and especially if it's something you can't put in a drill press to get it straight, you're going to drill it by hand, and you're really careful, and you're looking. Chances of you drilling it off sides are extremely high because you've already got a straight hole right there. You're just going to booger it up. So get your helicoil tap out and attempt, without too much pressure, to go ahead and do the threads. And I got to say, out of 200 holes, probably 199 of them I didn't need to drill, or maybe even 200. Just got to be careful. Don't break that tap. So maybe instead of a 1/2 to 3/4 turn, it's a 1/4 turn and then break it off, and a 1/4 turn and break it off. But you'll never see me drilling a hole. You don't need to.
Go straight to the tap.
I go straight to the helicoil tap.
So most of the time it's cleanly the threads are drawn, that you can just tap it from there.
Yep. Yeah. Now, if you were to take a drill bit and say, well, is it the right hole? It's not. So I'm not going to write this down because, it's not the proper procedure. And just know that if you're not careful, you're going to break the tap. You could stress something. But for the most part, it really, really works. The guy was right. And so that's the way I do it. Rather than drilling a hole and now you're bolting something and you got, maybe there's 4 bolts and you've screwed up one. Well, then you got 3 bolts going straight down, one at a crooked angle. And then you put whatever it is you're going to try and bolt to it, and the bolt will no longer go in because you got it crooked. So it won't fit through the first thing to go into the hole. And so now you're really screwed. I mean, you are beyond screwed at that point. So, helicoil. Now, it's funny, helicoils, it's like they're not FAA approved or anything, but it's just an approved thing to do. I don't know how it ends up that way, but it's an acceptable practice. The repaired thread is stronger than the original thread. High-end products because it's labor intensive, we'll actually put the helicoil in on a brand new component. So helicoil uses a special size tap. Don't try and, it's a helicoil size. It's not something, it's not the next size up. It's a special helicoil size, special size tap. And stainless steel wound, I'll call them springs to repair threads. So officially it's drill out stripped threads. With drill bit specified. With the drill bit specified in the kit, tap with special tap. Insert the helicoil. And you want to make sure that the top of that helicoil is, an eighth to a quarter turn below the top, below the surface. You don't want that first helicoil where the end is to pop up, and then it's just kind of, you have to start all over again. You got to take that one out. And they're hard to get out once you break the tang off. You got to actually pull a piece of it and then grab it with a needle nose and unwind it, and it can damage the threads and stuff. Make sure you break off the tang. I'll show you that. And I don't need to write this. Repair is as good, if not better than original. I'll write it, whatever. Is as good as or better. Break off the tang, T-A-N-G. What am I missing over there?
He just shit himself.
Is as good or better than original. And let's see. Yeah, I'm not going to write this one. Some manufacturers insert helicoils into soft metals during the manufacturing process. They just start with it right away. It just makes the threads just that much stronger. So, all right, so we got that. Yeah.
Would you ever add that you did that in a logbook or 337?
Oh, absolutely.
Yeah.
Oh, yeah, yeah. I have no shame of this one. You're not doing anything wrong. So.
You're kind of just notifying possibly the next ASB that.
Well, okay, so I'm building an engine,
Yeah.
and I'm putting the accessory case on and one stripped out. Now, I probably wouldn't mention it in the logbook. Not because I don't want to or I'm ashamed of it. It's just because, I don't know, it's just part of the building process, and I probably wouldn't think of it when I was all done going, well, what did I do here? It's just, you know, a little bit
If you did a
too
lot,
minutia.
if you did like a bunch of them, then you would.
Probably
No,
wouldn't.
okay.
Just wouldn't.
It's not that big of a deal.
Just not. Yeah, it's.
And people really wouldn't see it, wouldn't it get kind of overlooked if you're doing it with a whole bunch of other maintenance?
Yeah, because you're doing so much other stuff. It's just like it's almost because it just skips your mind because it's such a minor thing you did. You know, it's like, I didn't write that I tightened the rocker box covers because, you know, it's what I did. You know, it's part of it. And I was trying to think if it was a specific thing, like I'm working on the airframe or something, or maybe if I was working on my airplane, and let's say I had a leak in the engine or something. One of the covers was leaking in the back, you know, where maybe the vacuum pump cover or something, and I went to tighten it. Because on my airplane, in the back, you've got one where the vacuum pump goes, and the other side, there's nothing right there, and there's a cover. So let's just say it was leaking. So I went in there and I thought, well, it's leaking. I should tighten it up. So, I look up the torque on those, and then I get my torque wrench out, and I go to tighten up the bolt, and it just, oh, well, there's a problem. Whoever put it in, tightened it till it got loose and backed it off a quarter turn. Now it's leaking. So I would make a log entry. Found this cover bolt leaking. Bolt was stripped. Removed cover. Did a helicoil repair, reinstalled with new. Yeah, I'd totally write that.
Okay.
So there it is. You're going to get to do this. These little tangs right here have a notch cut in them. So to get them out, there's this tool. Hit it with a hammer. You're done. There is an insert. This is the insert tool, but there's also, I don't think I have a picture of it. I don't. You don't need it. You can just use that. But there's also a little, usually a plastic thing anymore, where you can actually insert it and it kind of starts the thread. It's kind of weird. I can show it to you.
What that thing was.
It's just an option.
Centered in the hole, or?
It doesn't even center it. It's like, but it expands the insert to the right size in that tool before it goes into the part, which I don't really know why they have it. It's just easier just to use this piece right here.
I just,
Yeah.
When somebody's doing it next helicoil, let me know, and I'll show you how to use that thing.
Yeah.
So, oops.
Kevin?
Yeah.
Were you saying that example with the strip bowl of the cover or whatever? How do you make the logbook entry of that? Is there something about in AC 4313 about helicoils, or how would you?
There is, yeah.
Oh,
Yeah.
okay.
It's a standard procedure, an acceptable procedure. I would say not approved, but acceptable. Oh, you could look into the, I think some of the overhaul manuals, like for engines, tell you how to do it, so that makes it approved. So an airframe manual might even have it, for strip threads, do this, and then it's approved.
Okay.
Yeah.